In example 1, we're asked to find all exact trigonometric values for negative 135, and of course that exact is in all caps. I like to draw these angles right from the get-go. It helps my brain kind of think about where they are, and then also can clear up some misconceptions as well. So here's our coordinate plane. We remember that the initial side here is on the positive x-axis. This negative 135 means rotate down first or in the clockwise direction by 135 degrees. So 135 degrees is going to be right here, or negative 135 degrees. There's a few different ways to tackle this problem. Some of you will note that if we add 360 degrees here, that will wind up with a coterminal angle, and that coterminal angle will be 225 degrees. Turns out that that terminal side here of 225 will lie on the same side as the negative 135, they're coterminal, and so actually the trigonometric values will have the same values for 225 that they would for negative 135. So if you like to think with positive angles, you can use this one. If you go to your unit circle now, you'll note the value of x in this case is negative root 2 over 2, and the value of y is also negative root 2 over 2. On the unit circle, r is 1. If you take a different approach and don't use your unit circle, you can use the reference angle for this, and the reference angle is simply this angle right here. Remember, that's the angle between the x-axis and then also the terminal side, and it's going to be between 0 and 90. That reference is 45 degrees. And so if you prefer, you can draw a little reference triangle right here, and we know this is 1. So in this triangle, not worrying about negative signs right now, we know that if the hypotenuse is 1, that each leg is going to be root 2 over 2. And then all we need to do now is think about which direction we're going to get to this point. So we're going left in the x direction, so that will be negative, and then down in the y direction, so that will also be negative. So lots of different approaches you can take. If you'd like to use that reference triangle method, go ahead. And then here, this would be looking like kind of straight on your unit circle. The radius here is 1 whenever you're on the unit circle. We now have x, y, and r, so we can set up our trigonometric values. We know that sine is y over r. So y is negative root 2 over 2. R is 1. We know that any value divided by 1 is just that same value. So the sine of theta is going to be negative root 2 over 2. The cosine of theta is going to be x over r, which is the same thing. X happens to be the same in this case, so we can correctly state that the cosine of that angle, and you can even put in negative 135 here if you wanted for theta, but that's negative root 2 over 2, because in this case we know what theta is. It's negative 135 degrees. The tangent is y over x, so that's negative root 2 over 2, that's our y, and then over x, and x is the same. So anything divided by that same thing will be 1. If we find our reciprocal trig functions, which we could have done originally here too, we'll just take this fraction and use the reciprocal of that. That's a negative sign, by the way, it kind of looks a little big. And then we'll rationalize our denominator. So we've got negative 2 root 2. Maybe this is going off the screen here. Move that over just a touch for you. And then that's going to be over 2. We can simplify this part. So that's 1 over 1. Leaving us with just negative root 2. The secant of theta, in this special case, we don't have to go through this whole mess again. As long as we did a good job the first time, it's going to work out the same. You'll notice that the cosine of theta is the same as the sine of theta in this case. So if we take the reciprocal of the same thing, we should get the same value. Tangent here, to find the cotangent, we'll just take the reciprocal of 1, which is 1 over 1, or just 1. So in that case, it turns out to be the same thing.